Thank you so much for having me here. Am I audible? Yeah, perfect. Also, thank you so much for coming here. I hope you had a good lunch. So, uh, before jumping into that, let me give you a brief introduction about myself. My name is Biru. I'm a co-founder and CEO of Limpio. It's a visitor management system where we provide a very seamless visitor entry to the gated premises. So it's an earlier stage startup. Beside that, I'm also a technical advisor at Betterhalf. Now it has been renamed to the wedding company. So yeah. So before we move further, I'll say how many of your engineer? I think I don't know the audience. How many of you engineer and DevOps? Could you please raise your hand or something? Most of them are right. So we talk about resilience. Do you, could you please tell me why do we need resilience system? What is the purpose of having a resilient system? Anyone? Like we build a system. I think most of them are, let's say if I talk about from the startup perspective, do you think we need a resilient system for a startup? Anyone? Okay, so for a startup, right now, we don't need that much resilient. What we focus is on mostly on the functionality should work fine. That's all we focus. But as we start growing further, we start, the startup start becoming bigger company. It is very essential for us to have a resilient system. Why? Because I think recently I think couple of months back we got to know that okay, the UPI was not working, right? I think lots of you must have faced this problem or must have heard this news, right? Why did it happen? The reason it happened because, see, the system was not that much resilient. It was couple of hours the system was down, and the second, if I talk about, there is another thing happened last year. There is a CrowdStrike, a company called CrowdStrike. There was some kind of problem happened in that. And because of that, lots of, I think, more than hundreds of planes were grounded. They couldn't fly. Company lost more than $500 million in that, whatever the problem that happened, in that outage. And the reason is, again, the system was not resilient. Can we make a system resilient, 100% resilient? No, we can't make a system 100% resilient. System is doomed to fall. Any system, whatever system we make, they have to fall sooner or later, right? But the problem is not about that, okay, system will fall, right? It has to fall. But how we can make a system which can create a lesser number of impact. Let's say I talk about UPI, right? Or like, I'll give you an example of Netflix. Imagine a Netflix system which was, the video upload is not happening. Let's say movie is not getting uploaded in Netflix. But Netflix can still work, right? I can still watch the video, so the read quality and the Netflix will work fine. At the same time, I can still watch the Netflix with the lower quality of video. So when we talk about resilience, this is what it's basically we are going to talk about. That system will fail, but it will not create a complete outage for the system. Like we saw in case of UPI, we saw in case of CrowdStrike and all the things. If the system had to be a high resilient system, the problem would not have happened that big, large scale. The problem would have happened, but it could have been contained till a certain point. Why should we focus is, whenever this kind of problem happens, as I mentioned, the company loses millions of dollars. There was a Facebook outage happened in 2021, where Facebook was down for a couple of hours. There was some bug there, and because of that, they lost around, I think, $300 million revenue, the ad revenue. Also, the reputation takes a hit. So it's very important that our system should be, resilient. Now, 10 years back, this might not be that big issue, but now it has become a very big issue. This user expectation arising. There is a case study was done by AWS, where it was told that in Amazon website, that whenever there is a 100 millisecond delay happens, their sales gets down by 1%. So they have come up with that. Similarly, when 200 millisecond latency gets added into the Google, the searches of the Google has gone down. So this kind of things since user expectation rising, it's very important that we need to know that, okay, if system is working, how far the system is responding, how much time is taking. If we add some kind of delay, what exactly is going to happen? So today we are going to talk about certain thing. We are going to talk about how we can make a system as a architecture as resilient. What is the fault-tolerant system, right? Technology and some architecture pattern we'll see, and we'll see a real-world case study. Given how much time is permitted, we have a 30 minutes time, we'll see how much we can cover in that. Okay. So when we say resilient architecture, right? So as I mentioned, the system has to be failed. No system is failed. You know, every day Netflix fail. They have thousands of microservices every day. Not a single day when Netflix says they don't fail. They fail. It doesn't mean that the system is totally down. Since they are used the thousands of microservices, I have closely worked with the Netflix team and all, so I know their system. But every day they deploy some of the microservices. They keep deploying that, and there are certain problems happen. But they keep fixing that. We as a user never get to know why, because system has an auto recovering mode. So a system fails, but system detect there is some problem. System automatically basically fix those issues. How do they do that? Something will also cover that. Mostly there is a one thing, very easy way we do that always in a, let's say when we use AWS or something, we see the auto scaling, right? So whenever there is a spike, surges happen, some of the requests gets dropped, but because of auto scaling, some auto recovery also happen with that. Zero downtime experience, is it possible? If you see, that is not possible. No system can claim that's a zero downtime experience. It is, again, as I mentioned, it's for us, we don't see that, this kind of problem from our side, right? But this keep happening. Zero downtime is a myth, it does not happen. These are the, again, our best resilient system as I talk about. Netflix is a very good, very, very high resilient system. Swift, how many of you know about Swift? Swift, you know something? Okay, Swift is a bank, right, where all the transaction, the intercontinent or the country-wise transaction happens. One of the very high resilient system, handle more than millions of requests per second, something like that. S3 is again a very good resilient system, also very high durability, talk about 11.9 and 11.9 as such. Beside that, there are other resilient system I talk about, like our stock exchange. It's a very high resilient system. Have you ever seen stock exchange getting down or something, right? Generally, it definitely happens sometime, but again, it is not visible to us. I think couple of months, we must, if someone uses stock exchange here, I think we heard that stock exchange was open on Saturday. Do you remember? There was a, right? Because they were testing exactly the resilient system. They were testing if the disaster recovery things work or not. So again, this kind of things keep happening. Some, again, as mentioned, for the entire day that I remember, stock exchange was open on Saturday just to test if disaster recovery system worked for them or not. So again, whenever we say the resilience, there are certain things comes in our mind. What comes, like, we always get confused at what is the meaning of resilience. We think, okay, if infrastructure is good enough, that means system is high resilient. But it's not about infrastructure, right? It is about multiple things, right? Infrastructure, obviously, it's a very important thing. Or the infrastructure should be multiple region, multiple country, so that the data could be replicated. So infrastructure level is there. Other thing, when we talk about resilience, your application should be resilient. Means your application should have the redundancy. You need to have multiple application copy running at the same level in a stateless mode, mostly. Then we talk about data layer. So database also should be replicated to multiple places, right? So data level resiliency is also important. Another thing is monitoring. Again, we generally overlook the monitoring part, right? How monitoring helps in the to make system resilient. So I'll tell you example. In 2016, I was working in Mobi at that time. I then quit the company and joined as a founding member in 2015, a company called Hansel. So we used to fix a real-time bugs in the app at that time. So you don't need to release a new version of app all the time. Okay, come to our dashboard. We'll provide a dashboard. You can fix your bug, and your app will get fixed within 15 minutes. Okay. So that's something we had built that time, and it was an instant hit. We call it stability. And every company, talk about Tokopedia, Paytm. At that time, Fresh Menu was growing very fast. So Fresh Menu, these are the cult fit. This company was using our system. So because of the demonetization happened, the Paytm request shot up like anything. Like our system was 1 year old. Our system was not that good right now. We were just working on that. And because of Paytm request has gone so much that our system was not able to, to basically take that load. So Paytm, at that time, the Paytm system was not that good. Like there was so much problem the Paytm had. One of the problem Paytm did that at that time they were using wallet. There was no UPI at that time. So mostly you transfer the money into the wallet and then use that. And if you transfer wallet money back to the bank, they charge some certain amount. So they were charging around 2.5%. So Paytm released their app, mentioned 0.25%. They made this blunder that rather than 2.5%, they mentioned that 0.25% charges they need to pay. They realized that and they fixed that issue. But since our system was not working, they couldn't fix in the real time. So if they go with the existing conventional way, it will take them to fix it 3 to 4 days. They will need to fix the bug, they need to test it, they will submit to the Play Store, App Store, and after the approval, they can release in a role-wise basis. So they told us that our system is not working, and we again fixed that our side. It took us a couple of hours for us to fix all those issues from our end. So had our system as a very good monitoring as such, we could not have faced that problem. So as again your company start growing up, monitoring is the most important thing. We generally in India overlook the monitoring part. So if you have a good monitoring system, you can figure out, even your client tell you, right? When client tell you that okay, system is not working, it's not a good situation, right? We always feel not good in that case. So I would say monitoring, whatever monitoring you use, whether you use Grafana or something, system level monitoring, application performance management, but please do that. And the most important thing in a resilience checklist is a human. Because we human are the one who makes the mistake the most. We generally again overlook here, okay? We think that, okay, infrastructure is fault tolerant, application layer we use ELV or whatever, data layer is that we are replicating, but human are the most, is the one which makes the most mistake. In each organization, what we do is we always make sure that, okay, there is one person who knows everything in our organization, who knows how to deploy in production. What if the person falls sick? Do we have any kind of redundancy? Do we have any other person who has the understanding of the system also? So it's very important that the person should go for a leave, other person should take responsibility and see that in case of any problem happens, like system goes down, if that person can handle the system or not. So what are the challenges we face basically when we talk about resilience? Why is that so critical, and what are the problems we face? So one is about, as per the CAP theorem, we know that if there is a partition is there, either you go with the consistency and availability, so that is there. The other problem is if you have come up with the data ingestion layer, like last speaker was talking about, a lot of layer as such. If there is any, it could break in at any places. If you have a good observation, good monitoring system, then only you will get to know where the problem is. If you don't have good monitoring system, you will never get to. You will get to know, but it will take a lot of time. Again, there is a third-party dependency. Every system, whatever system we use, we can say that we use, let's say, just pay, razor pay, right? We use for analytics, we use, I would say, mixed panel, clever tap. If those system goes down, how will you make sure your system is resilient? Whatever the code we write, again, the human comes into the picture, schema breaks if the code is not written correctly. Again, lack of visibility, as I mentioned about the monitoring. So it's very important. So because of that, the challenges in resilience is high. How can we make our system resilience a very high resilience system is, again, if your system has redundancy, it's a very important. I think all of you know what is redundancy, so I'm not going into that. Loose coupling, if your system is a loose coupling system, it's important. Graceful degradation, as I mentioned, right? If your system outage happens, your system does not go shut down. Your system's small part should goes shut down or something like that, or it should work with a limited capacity. It should not that, it should completely break down. Fault tolerance, if you are making a fault tolerance, again, it's a derived version of redundancy. If you have a redundancy and if you have a good way to manage the fault tolerance, you can do that. Observability, as I mentioned, is a very important part. And as you scale, scalability also matters. Now, when we say availability, right? When we say our system is available for 99% time, what does it mean? It means that in a year, 3 days, our system does not work. When we say 99.9%, means 39, we say in a year, our system is 8 hours not working. Similarly, for 6/9, your system is downtime for 31 seconds. Again, no system is 100% available. No system in the world could be considered 100% available, right? How can we increase the availability, right? How can we increase the availability, right? So this is a system here where there is a one more system is added. It's a kind of redundancy we talked about. If we have this kind of thing, if we have a single component and the availability of that system is 99%, if we have two like parallel system where the two component is there, your 99% goes up to 99.9%. If you have a 3 system in parallel, you have a 6/9. So if you had just redundancy here, your availability will go up, right? So okay, let me ask one question here. Let's say you build a system, and your system is you need a, let's say, 2 CPU and 2 GB system, right? Will you prefer to choose one server of 2 CPU or 2 GB, or will you prefer to have 2 server, 1 CPU, 1 GB each? Which will you prefer? What is the reason? Sorry? Fault tolerance, perfect, right? So exactly the fault tolerance, it will increase your availability. Again, if your system goes down, not all the requests will be lost, right? Let's say if I retry, might be the request will go to that system, and then it will work fine, right? But the problem is that if your system will come later, that if you use 2 of these, let's say 1 core, 2 core as such, but if the system is not able to handle, then problem is a cascading effect will come into the picture. So we need to also focus on how we can manage the cascading effect. Because your system, 50% chances will system work, but 100% request will come to that machine. And if your machine is not capable of handling 100%, 50% only, that machine will also goes down. So we need to manage that too. So when we say high availability strategy, how we can do that? We need to replicate our system into the multiple region. Replication is important, but we need to make sure the replication happens not to one in zone, but it happens to the multiple region as such, right? It's very important. Imagine there is a India-Pakistan war happened and they bombed one of our data center. Let's say we are using AWS or GCP. One of data center goes down, and if our data is there only in the same availability zone, even if you have a replication, your system is no longer high available. Your system, you will be out of the business, right? So second is apply failover routing. So let's say generally when you build a system, whether you use ELV, right? You use ELV, then you use multiple server behind it. What if your ELV fails? What will you do? Is that something we do that? Because that is also possible, right? ELV could fail, and it keeps failing though. So it's very important, again, so it's very important that you need to have multiple ELV as such, not a one ELV, multiple location, that one in, let's say, Mumbai, one is Bangalore or something like that. And there is a simple routing structure is there. You can have a weighted routing where request could go from one ELV to another ELV. DNS provide that. So it's very important. We should also use multiple ELV if you really want to increase the high resilience of system. If one ELV goes down, then request should not fail. It might add certain delay because that ELV is in some other location, but it should keep working. Health check and auto healing. Again, it's a kind of auto scaling which we keep doing that. And as much as possible, make sure that always use some kind of managed services, which I think everyone here must be using some kind of managed services, whether it's AWS, GCP, Azure, or some other, rather than using on-prem, because then that creates a problem. If you use on-prem, then you need to manage all this thing on your own. So that is there. Other, as I mentioned about, right, the dominoes effect, right? Again, there are two kind of dominoes effect happen. One is horizontal level, one is vertical level. When we say horizontal level means there is a ELV and there are multiple server you are using behind it. And if imagine that one of the server goes down, or if there is certain a spike happen in your request, one server will go down, and because other server is not able to handle those many requests, your entire system will go down. That is a horizontal level dominoes effect, right? And because of that, what happens is that you need to have certain kind of resiliency. So make sure either you can use rate limit, something, to make sure that each server can handle only this many requests. That is the thing. Second is vertical means if you have a data ingestion layer, some of, let's say you are using connection or database at the end of that date, and you are having everything in a tightly coupled things, like one server is making requests to downstream to another server is making requests downstream to another server. If one server, let's say you are using database, you have a certain number of connection pool, all of the connection pool are busy. What will happen in that case? Requests are coming to your system, but you are not able to handle those requests. So because of your downstream is not able to handle those many requests, your upstream server will start getting panicked, and they'll start either dropping the request, or they will also goes down, because all the thread connections are busy. So for that, it's very important to use event-driven architecture wherever it's possible. Again, in not all the cases, let's say in banking system, that is not possible. But wherever we talk about eventual consistency, it's very important to use event-driven architecture. And there you can use certain kind of queue. It also helps you to, if there is any sudden kind of surge happen, the system should handle that. So that is the thing. Now, another thing, whatever we talk about, okay, we need to make all the system, resilient as such. But another important thing is disaster recovery. How many of us here has ever recovered database in production? Any guys? Okay, you have done, right? So, but generally what we do, build the system, we take a snapshot, we replicate that to another region, right? But generally what we do, we don't, I think there are very few people I have done that, but I have seen in my organization, no one has done that. Because generally, this is a very extreme scenario happen, but sooner or later, this will happen. That's the question here is whether this is gonna happen or not. This gonna happen, it matters at what time happen. If it happens when your organization is very, is thriving a lot, at that time it happens. And if you don't know, and you are the one who is responsible for that, then this is a problem. So disaster recovery is very important. We should at least try it out. It's not that different, but actually what happens is when you are in panic situation and when you do that, you make a mistake, because at that time the mind does not work. The bosses will come to you, will start pondering that, okay, this many things happen. So it's important to at least try it out, okay? This is what exactly it's talk about, right? Disaster recovery as such. So there are two kinds of disaster recovery generally. One is about natural disaster. We know that, okay, if natural disaster happen, we all know that, okay, go to the AWS, keep making a snapshot, okay, and recover from a certain, whatever the recover last time you have taken snapshot, recover from that. There are other kind of disaster happen when there is a cyber attack happen. Let's say some hackers come and they destroy, like they either stole your data or they corrupt your data. That recovery is a very difficult, because the hacker might provide some kind of virus, some kind of anomaly in your data. So you need to check, is that any kind of problem happen in the data which has been already compromised. So those recovery is a different kind of recovery that needs different kind of expertise. So that is again a recovery, but again, that is a different topic. So you can check yourself where your resilient maturity, where do you stand, right? What we talk about, a system where there is no backup, all the thing manual fixes. These are the different level of resilient, okay? You can consider yourself where your system basically stand. Whether your system stand is a fragile, you don't have any backup. Generally, I think a startup works from that perspective, which is totally fine. But as you move to the ladder, there are different kind of that. Again, we talk about fragile, basic fault tolerance, automated recovery. I think till 3, graceful degradation, we need to focus on that as we start moving further. Beside that, later we can add more expertise as such. I think over the time, the AI-driven detection and recovery is going to take a shape as such. So I think that is important. in future, everything is going to be covered through AI. So this is again a pattern. You can use circuit breaker pattern. You can use back off. So whatever I talked about from the system level. I didn't talk about what if the request starts going up a lot, how can you handle? So you can use either circuit breaker pattern, you can use the retry timeout as such, that okay, how much, if there is a request comes, if request fails, you add a retry mechanism, make sure you add the exponential timeout there, that 1 second, 2 second, 4 second, and make sure you also use the write ahead logbooks, so that if there is any problem happens, you know exactly from where you need to recover your data. So that is there. Again, as part of the real world example, I'll just talk about a chaos monkey. Again, it's a next level thing, but definitely if you want to try, you can try. A company like Netflix and all those things, keep using that. Again, in not all the system you can use it. Like, let's say, as I mentioned about the stock exchange can't use chaos monkey, but the system which we build, like Facebook, AWS, this Netflix, keep using the chaos monkey. They deliberately shut down certain server and see how much, if the system works fine or not, if system automatically respond or not. So this is an open source tool also available. You can go and check it out. Try it out in your system, see how your system works. If your system fails or your system passes, so please use that. S3, again, as I mentioned, the 11.9 seconds. So again, 11.9 durability. There is a time in AWS S3 failed in 2015. Lots of system goes down. I think at that time GitHub was using and all this. I think 2018. I don't remember exact time. GitHub failed and all. Whoever using S3, right? Till then, S3 has basically again, as I mentioned, system will fail, but they have created a system where the impact of the system will go down. Will not that entire S3 will go down. Might be the put request will not work, get will work, or get will work, put not work. So they have changed the entire structure from that perspective. I thought to add that, but again, our system is very small, so I have not added it here. I would say the takeaways from this system is, from this session is, design for failure from day one. So when you say design, don't implement, because if you are a startup, I would say focus on the functionality, don't focus on resilience. But you should know exactly what will happen in case certain thing goes down. But if you're working in a big organization, make sure you have some idea. Make sure your organization have certain kind of thing. Talk to your seniors, see that how much resilience, how much confident your senior, or and if you are C-level person, make sure you have idea. Someone in organization, not one, but 2 persons should have understanding that if the system goes down, how can we work on that. As I mentioned, use some kind of some managed services, because that is important. And again, as I mentioned, resilience is a journey. It's not a destination. It's not that today you'll go and say, okay, I'll implement the chaos monkey, or I'll do that, this, that. It will take time. It will take its own journey, but you should have some idea. I think that is very important. Yeah, that's all from my end.